Assalamu alaikum. Today we will study the use of the standard normal tables in normal distribution. The standard normal distribution has tables of ordinate, area table, cumulative distribution function, but in the normal distribution tables are not available, and we will use standard normal table in the normal distribution. We will study a few theorems for this theorem 10.5, in which it is stated that x is a normal variate with mean mu and variance sigma square. Then the shapes of the curves of normal distribution is given on the left side, and shape of the distribution of standard normal is on the right side. You can see that the shape of both distributions are similar. Both are symmetrical, both are bell-shaped, both having the central value at mu. F of x is for the normal distribution, which is the title of the curve, and on the right side phi of x is the title of this graph of this density. So this is the standard normal curve, in which mu exists in the center, which is not mentioned here, but we can see the scale starts from -3 up to +3. Definitely there must be 0, and we know that standardized variable z is normally distributed with mean 0 and variance 1. So in this case mean is 0 and center line exists at 0, and on the left side it's a density function of a normal distribution whose mean is mu, which in this case is 10, and its range, which is here, is 5 to 15. There are 2 points on both curves, and these 2 points are on either side of the tail, or either side of mean. So the ordinate is the maximum point of the curve, which is here 0.4, and which is also calculated by its density function, probability density function. Whenever we substitute the values of parameter in the density function along with the mu mean, then we will get the ordinate, maximum ordinate on that point, which in this case is 0.4. Okay, theorem states that if x is a standardized, if x is a normal distribution with mean, mu and variance sigma square, then capital F of x is the distribution function which starts from -infinity to that point. If this point is here, then this shaded area is called the capital F of x. If x comes to this point, then the shaded area below this point is called capital F of x. This is our shaded area below this point, which is called as capital F of x. So capital F of x starts from this one, and in the figure of standard normal curve, it's the point on the z-axis, and capital phi is the shaded area starting from -infinity, which is here, starting from this point -infinity up to the specified point, is also called as the capital phi. So capital F and capital phi are the distribution functions of normal and standard normal distributions. At the specific point in the normal distribution, we have corresponding point in the standard normal distribution. For example, if I plot a line that this left side corresponding value is on the left side. So initially we will calculate x point on the normal distribution, convert it into the z score, and z score lies on the z line. This is our z line and this is our x line. So x is converted into z. If I mention it here with a different color so that you can identify that x is converted into z, and this conversion holds by this formula. So formula is standardized variate is z is equal to, so it's a z score, x is the value on x scale, z is the value of at z scale, x minus mu, specified value of the parameter in the normal distribution, over sigma. By using this we can convert x into z score. Now we will come to the next slide, in which we will study few theorems which are related to this inverse use of standard normal distribution into the normal distribution. This is the theorem 10.6, in which three axioms. First one is probability x less than small a is always equal to phi of a minus mu over sigma. If we plot this point on the number line, if I plot a scale here, this is our x scale, corresponding this is z scale. We will write it as x and this one as z, and the curve above this line is this one. The central value is here, which is always equal to mu if our scale is x, and which is equal to 0 if our scale is z. So A is the point. For example, this A is the point here on first axiom. If we look first axiom, where x less than equal to a, and a is on the x scale on the left side, for example on the left side, but you can take it as on the right side. So we have to find corresponding value on the z scale. This value is called z score by the formula z is equal to x minus mu over sigma. Z is equal to x minus mu over sigma. Standardized variable. Z is our standardized variable. This is sigma. So by using this expression, we can find the corresponding value of a in z. So substitute a here, and for given values of parameters, mu and sigma are given, and for specified value of x we can find z, and this corresponding z exists on the z scale. For example, this value is, now we will calculate it, for example, and it is here z1. If I write it as this is z or z1. So this less than sign shows we have to color below the point A. So shading is on the left side of A. So we will shade this area, and probability and area are same. So this is the probability less than A, or we can see that it's a area below A. It always starts from minus infinity to that point. In our case, here is in both scales, here minus infinity, and on right side it's plus infinity. Also on the z scale there is plus infinity on the right side, and on the left side it is always minus infinity. So shaded area will be from minus infinity to A, and we can use area table of standardized variable once we get the value of this z by using this expression. Next axiom is, if our distribution function, if our function has value a on the number line and area x greater than equal to a, so we have to shade area above this point. If I shade a different color in this same figure for this area, for example blue color, this is the a point and the shaded area above this point, because there is x greater than a, so we have to shade the righter tail area, which is this one. Okay, this is our area x greater than a. So this is the area x greater than a, and we know that the total area under this curve from minus infinity to plus infinity, this is minus infinity and this is plus infinity, and the total area under this curve is always equal to 1. So if this area is 1, and we know this area minus infinity to a is, this area is called phi of z, small phi, capital phi of z. This area is phi of z. If phi of z is given, then we can find right side area by subtracting 1 minus phi of z. So 1 minus phi of z is this one, because a minus mu over sigma is z, by substituting a here. So phi of z is here, and we can find blue area by this expression. So theorem number 2 will be used if we have to find area below this. So this is the expression. This area is for the second part. In third part, there must be 2 points on the x scale. Consider one more scale. So this is our x scale, and z scale. For example, this is our z scale. Then the figure here is this one. Center, always mention center first, is on both lines. So here it must be 0, because this is z scale. Here it is x, and up on x there must be the mean, and mean is equal to mu. So a and b are the 2 points such that a is less than b. So a must be before b. A is, for example, here, and b is here. Both a and b can be on the right side or either on the left side. So we have to find corresponding values of z scores on here. For example, this is our z1 and this is our z2. So both z1 and z2 are obtained by these formulas, x minus mu over sigma, and after substituting we will have b minus mu over sigma and a minus mu over sigma. So these are z1 and z2. Once we get the z scores, we can use phi table, capital Phi table, find the areas and subtracting. So less than sign shows that phi probability A to B, from A to B area would be colored by the green color, for example. And we know that capital Phi, the table gives us the area starting from minus infinity to that point. If I am taking that the area is this one at the point B. If I look the table at phi of z2, this area is actually phi of z2, and phi of z2, capital Phi of z2, table gives you capital Phi of z2, which is not required actually. We require the green area. And when you see the value on z1, it will give you the area from minus infinity to z1. This area will be given if you will locate your z1 starting from minus infinity to this point, which is also not the required one. But if you subtract phi of this is our phi of z1, this is phi of z1. So phi of z1 is subtracted from phi of z2 will give you the required area, which is green area. So this is phi of z1. So phi of z2 minus phi of z1 gives you the green area. After the theorem, we will come to the next theorem. The next theorem is 10.7, in which we have to find the ordinate of the normal distribution using standard normal distribution. You can see that it's a curve of the normal distribution. Small f of x is the title of the curve. X is the scale. In the center, mu is equal to 10 is given. So we can write it as this is our mu. For example, this is our mu. And the specific point, for example, that specific point is 8. We can find the height of the curve. The height is actually the ordinate. We know that at x, the height is this one, which is calculated as, or we can view it from the curve, it's 0.1085. So we can obtain this height in two ways. First one, substitute 8, mu 10 and sigma of this distribution, which is given. So all three values in the density function of normal distribution, PDF of the normal distribution, and get the value of 0.1085. Or if we want to use the standard normal table to find the ordinate of the normal curve. So other second method is uh, substitute this 8 here. Phi of c, phi and f both are used for the density function. Small f is for the normal density function and small phi is used for standardized normal density function. So we will substitute a here, mu and sigma are the parameters. All three values will be substituted in this expression, and expression give you some value here. So phi of that value, we will locate that value in our table. Table is given ordinate table, which is I think 7 table, and then you will have your ordinate. The ordinate would be the same, 1.1085. So theorem 10.7 is used for the ordinate. So now come to the example, and this is our example in which it is stated if x is normally distributed with mean mu and variance sigma square, then find ordinate at x is equal to 42.5. 42.5 is any specified value, also maximum ordinate. If mu is given here as 40 and sigma is given 5. So in this example, come to the book. Here in the book, it's example 10.6. If x is a normal random variable with mu is equal to 40 and sigma is 5, then write down its density function. Find the ordinate of its normal curve at x is equal to this one, and also find the maximum ordinate. So we will find its ordinate at 42.5 by this expression. This is f of a by the theorem 1 over sigma phi of a minus mu over sigma. In our case, a is 42.5. So we will substitute 42.5 here. A is also replaced by 42.5. Sigma is given as 5 and mu is given as 40. So all these values will be substituted here and the expression will give you 0.2 phi of 0.5. And so this 0.5, phi of 0.5, we will locate it in the table 7. This is our table number 7. Yes, this table gives you the value 0.5, which is 0.35207 here, corresponding to 0, 0.500. So 0.35207 will be substituting in this expression, and our final result is 0.070414. This is one way to find the ordinate. The other way to find this ordinate is by substitute this 42.5 directly in the density function. So in the density function, 1 over sigma 2 pi under root, sigma is replaced by 5 and the mu is by 40 and x by 42.5, and calculate it, we will get 0.0704131 which is similar to this one. In last part of this example is also find maximum ordinate. We know that the maximum ordinate is always at mu. You can look in the figure, and the central value is the mu, which is 40. If we substitute this 40 in the expression instead of 42.5, we will get the answer of maximum ordinate 0.079. So the height is, which is blue line, and the ordinate can be studied by here. It says 0.097885, and 42.5 is definitely positive, so it's come next to 40. So this is our red line, which is at 42.5, and its height can be read from this line, which is 0.04131. So both are the ways of calculation, first by the density function and other by using the standard normal table. So that's all for today. Thank you so much. Allah Hafiz.